And welcome back. As we go ahead and jump right into our next topic, we've already talked about the basics of doing generic classes, but now we can take those same ideas and apply them to generic methods as well. So, like I said, as we talked about how to define generic classes. And when we define a generic class, we can actually use that type parameter into the definition of methods that exist within that generic class. We can also define a generic method that has its own type parameter that is not the type parameter of any class. So if we look at this example, we say a generic method can be a member of any ordinary or non-generic class, or a member of some generic class that has some other type parameter. So let's say we have a public class utility, and we're saying public static t, and t get midpoint, t array a, and then returning array of a dot length dot, or of 2. And you can see here's our other static method. You can see we can get first, and you can notice here we're again passing into a and returning a of 0. Notice both of these are not of type utility. They are a generic here because we're using this t here in both of these methods. Now, type parameters and modifiers exist when we start looking at these methods as well. In this case, the class utility had no type parameters. The utility was just an ordinary class. But the methods of both get midpoint and get first each have a type parameter. And you notice that the type parameter is in angular brackets t, which is placed after all the modifiers, in this case public static, but it is before the returned type. So when you invoke one of these generic methods, make sure you preface the method name with the type to be plugged in, given in angular brackets, such as the following examples. String midstring equals utility dot string get midpoint b. Double first number equals utility dot double get first c. And again, you'll see, if you look at this, this is our type here, string. This is our type right here, double. Now, generic methods, again, are very similar to what we might expect how to call and invoke for our ordinary methods. The dot before is the type in angular brackets. The type part of the method name, though, is not part of the class name. You also note that the methods get midpoint and get first use a slightly different types that are plugged in. One was string, one was double. The type parameter, therefore, is local to the method, not to the class. The argument b, of course, was an array with base type string. The argument c is an array with base type double. And, of course, generic methods can also exist not just inside of ordinary classes, but they can also exist inside of generic classes. And if we say, like, okay, we got a generic method inside a generic class, we say type t and viewer type are different type parameters. And if we look at this class here, all right, t is a type parameter for the entire class. However, viewer type is a type parameter only for the method show2. And if we look here, t, of course, you see it's right here at the class level. And so there's private t data right here, so it is a class type. But then we look at viewer type, we have show2, which means that this is now a type parameter just for that method. Now, when we actually output that code, let's say we were running execute, what would we see? Well, if we want to use those methods, let's say we say sample, we pass an integer, object is new sample integer 42, object dot string show2 friend. It's going to produce the output, hello friend, data is 42. Now, inheritance, of course, is a very big thing here with generic classes too, because obviously if we have a class type, one of the big things that we can do is create derived classes. So you can define a generic class to be a derived class of any ordinary class, or even the derived class of another generic class. And we've done that here with the unordered pair class, which contains a definition for a generic class called unordered pair, which is a derived class of the class we looked at last time, pair. The class unordered pair overrides our definition of equals that it inherits from pair. And a programmer using the class, you'll see unordered pair is just like the class pair, but with one exception. In unordered pair, the two components do not have to be in the same order for two pairs to be equal. Let's say in the pair string world, we use cashews and peanuts. All right, we'll say that is not the same as peanuts and cashews. However, in the unordered one, all right, if we look at pair, because pair, they have to be exactly the same order. Unordered pair, as long as you have peanuts and cashews as your two choices, doesn't matter which way they go, they're going to be considered the same. All right, so if we start pulling apart this inheritance, we can look at this in the unordered pair demo. And just as we might expect, an object of type unordered string pair is also type pair because it's inherited. It's got derived class in play. And as we've seen so far, inheritance with generic class is pretty straightforward. However, there are some situations with subtle pitfalls, which we will discuss in our next time. So, what is that next time that we want to see? Well, let's just say an hourly employee is derived from the class employee, and that's what we've expected to see. You might think, okay, well, if I have a derived class of it, and let's say we do a pair of hourly employee, and we say, well, is that also type pair employee? Because, well, hourly employee is derived of employee. And you might think that if I were to put those as, these type parameters, that this would work. Well, it's not quite so. And that's because if, let's say, we just have G as a generic class, there's no relationship between G of A and G of B, no matter what the relationship between classes A and B are. So even though hourly employee is derived of employee, when we look at those through pairs lenses, pair says, I don't care if they were related before. What I care about is my relationship, because pair of hourly employee is a different type than pair of employee. There is no established relationship between them. And so that's just one thing you kind of have to be aware of. All right, so real quick, if we look at our unordered pair here, you'll see we have our unordered pair class here, which is very similar to what kind of things we've seen before. Of course, this is simply extending pair, so nothing new that we haven't seen there. And you'll see here is our equals method, which has now been rewritten for this class. And in our main here, you'll see we take in our first string here, which is saying peanuts and cashews. Our second string, which is doing cashews and peanuts. So we'd expect that these, of course, using an unordered pair are the same. If this was a pair class, these would be obviously not the same. So if I go ahead and run that code, you'll see we get peanuts and cashews is the same as cashews and peanuts, because it's saying it doesn't matter on the order of these. And that's just something to keep in mind when you start looking at how generic classes are and how they can work, especially when we start getting into how things may be affected based upon the methods that we override and stuff like that from it being derived.